Welcome to Paths of Math. Today we're going to be practicing some SAT problems involving circles. This is going to include non-calculator and calculator problems. Let's get to it. For number one, we have quite the paragraph here, but to interpret these words, let's break this down. We have a circle being rotated 360 degrees. All that's saying is your circle is becoming a sphere. That's all that happens when they talk about the 360 degrees along the y-axis. Now it says the volume of the ball needs to be 36 pi. Okay, so that's the volume of the sphere. It does say to find the radius of the circle. So we kind of have to reverse engineer our way back into the circle, but that's okay. I know that the radius is the same for my sphere and my circle. It's the same exact radius. That doesn't change. It didn't enlarge or shrink. Now, in order to relate the volume to the radius, we have to remember the formula for a sphere. And that's going to be 4/3 pi r cubed. I could set these values equal to each other, the two volumes here. The volume that they gave me and the volume from the formula that we know, whether it's from the SAT formula sheet, which it will be on, or you have that memorized. We have 36 pi equals 4/3 pi r cubed. To solve for r, the first thing you want to do is multiply both sides by 3, giving you 108 pi equals 4 pi r to the third power. Now, you want to divide both sides by 4 pi. I know 4 times 25 is 100. I know 4 times 2 is 8. So 25 plus 2, that gives me 27. When I divide 108 by 4, you get 27. On the right-hand side, we have r to the third power. So we're looking great. We just have to figure out what number times itself 3 times is 27. And that number is 3. So our answer, the radius, is going to be 3. Okay, we took the cubed root of both sides. If you have a calculator, that's okay as well. This is potentially a great non-calculator problem though, so that's why I wanted to explain all those things in depth. If you have a calculator, this problem becomes really easy once you set up that equation. So don't forget to take the formula and set it equal to the value that they give you in order to find those variables. That's how we found r. For number 2, it's a little bit simpler version of what we just did. For number 2, they're going to say a circle with the radius of 4 is rotated 360 degrees. Find the volume of the sphere created. All right, so we know that the radius is 4, and I know that the volume is going to correlate. The dimensions of the sphere is going to correlate with the circle. So I know the volume is 4/3 pi r cubed. I could plug in the 4 into the r value. That's going to be 64, 4 times 4 times 4. And now I have to multiply 64 times 4. So let's do this in our head real quick. The 4 times 60 is 240. And then the 4 times 4 is 16. So I know 240 plus 16, 256. All that's going to be divided by 3. Can I simplify that fraction? If these three numbers don't add up to a number that 3 can go into, then you cannot simplify this fraction. 2 plus 5 plus 6 is 13. 3 doesn't go into 13. So don't waste your time trying to divide that. Don't waste your time trying to simplify that. That is your final answer. This is a great multiple choice problem. Non-calculator multiple choice problem. All right, moving on to number 3. Let's talk about arc length. Let's say they give us a diagram and it looks like we're cutting a slice of pizza. Now that slice of pizza is determined by the angle theta. All right, that's a Greek symbol theta. Or if you want, for simplicity, let's use the letter x. If x is a central angle, and is, let's say, 38 degrees, find the arc length BC. Let's label the A, B, and C. They're going to give us A, B, C, and they're going to give us the radius of 5. So we know that r equals 5, x equals 38 degrees. How can I correlate this into some kind of formula? So what we're talking about when we talk about arc length is the circumference of the circle. So there's my arc length, and the circumference is just the crust. So if you see this pizza shape, they could be asking for the area sector at times, which we'll see today. But in this case, I know they're just talking about the crust because it's arc length. Now, that is the circumference. So we know that circumference is 2 pi r. That will be on your formula sheet. But we only care about a specific part of the circumference. We don't care about the entire circumference of the circle. We want to multiply the circumference by a fraction because that's all we're focused on. We're only focused on a fraction of the circle, and that fraction is x over 360. X is that angle, the central angle, and that's the only part that we care about. So this is what our real formula looks like for a arc length, or an arc sector. You'll see is similar. 2 pi r times 38 over 360. All right, so we know r is 5. I'm also going to take the 2 and the 360, and I'm going to simplify those. So I'm going to have pi 5 times 38 over 180. If you have a calculator, go ahead and use it now. You're going to get approximately 3.32 as your answer. And that's going to be the units of measurement that they use in the problem. So it could be 5 inches. The radius, for example, if it's 5 inches, 5 centimeters, 5 feet, 5 miles, your answer is going to follow the same unit of measurement. All right, number 4. Another slice of pizza with a central angle. If the angle is going to be 40 degrees and the radius is, let's see, 6, find the area of the sector made by central angle theta. Okay, so we know that we're dealing with area, so we want to do pi r squared. We're no longer focused on just the crust of the pizza, we're talking about the entire pizza. So now we have to change our mentality to the area, and the formula is pi r squared for the area. Now, we don't care about the entire area of the circle. We only care about the area made by that angle, so we have to multiply it by the fraction, theta over 360. Now, this is something that I don't want you guys to memorize. I want you to be able to break down what's happening because you can relate it to all sorts of other problems as well. We're taking a fraction of the entire area. That's how we get this theta over 360. Now we know r, we know theta. All we have to do is plug it in. So we have pi times 36 times 40 over 360. If this were a non-calculator problem, don't stress out. Take things one at a time. All right, step by step. We have 40 over 360. That's basically 4 over 36, and that is 1/9, because 4 goes into 36 9 times. So I could cancel out the 40 over 360 and put 1/9. Now the way to interpret this is 36 divided by 9, and we know that's 4. So my final answer is really just 4 pi. That's the value or the area of the sector made by that central angle theta. Now what if we take the same problem and it says finds the area of the shaded region, and then they shaded in the rest of the circle, right? Kind of making like a Pac-Man. Well, then this becomes a multi-step process because I don't want the entire area, but I have to somehow find that shaded area, which means I have to first find the area sector, then subtract the entire area and the area sector. Now, if I'm going to keep the same dimensions, we know that the area sector is going to be 4 pi. we would have had to done that whole process just to get 4 pi. That wouldn't be our final answer in this case. We have to then plug in r to the entire area, right? Pi r squared. So that's going to be 36 pi, and subtract that from 4 pi, giving us 32 pi. So just to reiterate, I'm subtracting because I took away a pizza slice, and they're asking me what's remaining of the circle after I take away that pizza slice. All right, obviously this question has nothing to do with pizza, but I'm trying to help you guys relate to what's happening and how to interpret the question. All right, because once you understand what they're asking for and understand how to create an equation like what I did down below with the pi r squared minus the area sector, they're not going to tell you that, but once you understand how to do that yourself, the math becomes a lot easier. All right, number five. Slightly different. I know it looks like a slice of pizza. But what's different about this image from the image before? Theta is not a central angle. It is not a central angle. Let me label this A, B, and C. So if it said finds minor arc BC, how in the world would you be able to do this? This is something where you either know it or you don't. And thankfully, once you know it, it's really easy. Since this is not a central angle, but we do have these chords that are touching the circumference of the circle, the minor arc made from the angle, right, directly across the arc directly across the angle is twice the value of the angle. So BC equals 2 times, oh, I forgot to give you the angle. That would be very helpful. If theta equals 35 degrees, I'm so sorry, they would have told you that, guys. If so, for example, angle is 35 degrees, the minor arc would be twice that value. Excuse me. So we get 70 degrees, and that's your answer. That means that this section, let me grab the green marker. This section of the arc is 70 degrees. If that doesn't make sense to you, let me just remind you that a circle is a full 360 degrees. So we found out that this part is just 70. All right. Let's make this a little bit more difficult. I want to see if I could do this on the same time. Theta, AB. If line segment AB is a diameter and theta is not a central angle, and theta equals 30, let's just say 30 degrees, keep it simple. Finds the value of minor arc AC. Great. So we know very quickly that this arc BC is 60 degrees because it's twice the central angle, or not the central angle, the angle that is across from it. But how in the world can I correlate that with the minor arc AC? Well, they gave me a huge hint, and that's that AB is a diameter. It may not look like it in this image, I apologize, but they told me that AB is a diameter. What that tells me is we cut the circle in half using that line, AB. Half of a circle, as I just mentioned, a full circle is 360 degrees. Half a circle is just 180 degrees. So no matter how I cut this, both of those segments are going to add up to 180, right? Both of these segments here, no matter what their sizes are, if we add them together, they're going to give me 180 degrees. Well, guess what? I know the value of one, and I have to find the value of the other. Let's relate this back to our actual diagram. We're going to have 60 degrees plus the arc segment AC equaling 180. With some quick algebra, we get arc segment AC equals 120 degrees. And that's our answer. A little bit more difficult, a little bit more intuitive, but it's all the same rules that we're following. and the same concept of being able to come up with an equation. Interpreting those words, the math problem. All right. Number 7. Let's say they draw a triangle inside a circle, which they do like to do. Let's label this A, B, and C. Let's say AC is a diameter. Line segment AB is 3, and line segment BC is 4. Find the area of the circle. Okay, so let's label our diagram, right? 3, 4, and then let's also say angle A is 90 degrees. No, I'm sorry, B is 90 degrees. That typically may not have been mentioned in the word problem. It may have also been shown in the diagram just by that little square being there. So they could have brought that up in either of those ways. Either way, that helps us understand what to do. We have a right triangle and we have a missing side, so we can use Pythagorean's theorem. 3 squared plus 4 squared equals c squared. Now this is going to give us c equals 5. I didn't do the math in my head. I know that 3, 4, 5 is a special triangle. Now they mention this on the formula sheet as well, but you should get comfortable with special triangles. They like to sneak those in there a lot, and it helps speed up the math process significantly. So 3, 4, 5, you're going to be rewarded if you memorize that, and you could just label the diameter as 5. Now this helps us with finding the area of the circle because we know that the area of the circle is pi r squared. Since we care about the radius, we have to take the 5 and divide it by 2. If you want, you could write that as 2.5. That's what I'm going to do in this case, but either way, this is going to be a good calculator problem. You can use your calculator to do that as well. So we got pi times 2.5 squared. And then once you do 2.5 times 2.5, you get 6.25. Don't forget the pi symbol. Obviously, this would not be an FRQ problem. You have the pi symbol there, and that's not an option on the grid in response. So this is a great multiple choice option problem. All right, guys, that's going to wrap up our practice for today. Thank you so much for joining and watching. Subscribe for more. Leave any comments requesting other math content that you want to see, and I'll dedicate that video to you. Thank you again for supporting, and good luck on the SAT.